Hello everyone. First, the introduction to the phenomenon. Head loss is a measure of the reduction in the total head or sum of elevation head of a fluid as it moves through a fluid system. What it does is that it reduces both the pressure and the velocity of a flowing fluid. Head loss in a piping system is categorized into two kinds, major head loss and minor head loss. The one which we will be experimenting with today is the minor head loss, which is a head loss that is caused by the flow going through a component that alters the fluid flow characteristic. The objective for the experiment is to determine the minor head loss coefficient in a pipe accessory. The second involved is to compare the minor head loss coefficient of different pipe accessories. And the third is to compare the minor head loss coefficient to the value from the reference. Firstly, let's delve into the phenomenon that we will be experimenting, the flow rate. The water flow through the pipe can be assumed as a flow of an incompressible fluid. Since the fluid is incompressible, meaning the density only changes very little when pressure changes. With constant volume flow rate, and assuming the flow is fully developed, the mass flow rate throughout the pipe is constant. That means the velocity of the fluid through the pipe can be determined by using the fluid's mass flow rate. Next of all is the flow characteristic. The type of flow characteristic of a fluid can also be depending on its diameter, velocity, and fluid properties. The flow is usually categorized as laminar, transitional, or turbulent flow. The parameter of which the flow characteristic changes is defined by the Reynolds number. The flow in a round pipe is laminar if the Reynolds number is less than approximately 2100. The flow in a round pipe is turbulent if the Reynolds number is greater than approximately 4000. For Reynolds numbers between these two limits, the flow may switch between laminar and turbulent conditions in an apparently random fashion. Minor head loss. Most pipe systems consist of considerably more than straight pipes. These additional components add to the overall head loss of the system. Such losses are generally termed as minor losses. The head loss that is a common minor loss is generally associated with flow. This is because the different and changing geometry in the system alters the losses associated with the flow throughout the additional components. Now moving on to the experiment apparatus and the demonstration. As you can see here, this is the schematic of the apparatus. The first one uses 3 valves as the accessory. The second one uses 9 elbows as the accessory. The third one uses 3 valves and 4 elbows as the accessory. Mind you, the elbows here are 90-degree elbows and the valves here are ball valves. All of these accessories will make up for the minor head loss in which we will be observing.
From this picture, we can see the apparatus, which consists of a bucket, which serves as the water reservoir, a water hose that serves as the pump inlet, and we can see the arrangement of the system. It consists of a valve that we can use to control the flow rate, the pressure gauge, and the pipe arrangement. Short demonstration of the apparatus, but since there is some problem, the demonstration is so short, so we redid the demonstration, which will be shown in the next slide.
the second thing that we need to find is the velocity. And how do you find the velocity? Is by searching for the mass flow rate. We can search for the mass flow rate by looking at this bucket here. We should see how fast the pump is throwing out water into this bucket. And from there we can see, for example, we wait until the scale shows 3 kilograms, and then we set a timer to it and see how fast it spews 3 kilograms. And from there you can search the mass flow rate. Okay, so now the second thing that we need besides pressure is also the velocity. How do we search for the velocity? We can do that by searching for the mass flow rate. How do we search for the mass flow rate? We can use this bucket right here. We have to see how fast the pump is spewing out water out of this pipe. And from there we can see this, what is this? Jesus.
From the experiment, we collect 3 sets of data with different pipe arrangement. For the mass flow rate, we determine that we will measure the time when the mass reaches 3 kilogram, and then measure the time, and then we also measure the pressure using the pressure gauge. There are also additional data as assumption. For the calculation, we can find the mass flow rate by dividing the mass, which is 3 kilogram, divided by time it needed to reach 3 kilogram. Then from the velocity, we can use the equation of rho, which is the fluid density, times the m dot, which is the mass flow rate, divided by A, which is the area of the cross-sectional area of the pipe. And from the Reynolds numbers, we can use rho times v times d divided by mu. And we also can calculate the KL with the minor head loss coefficient by using the delta P, the pressure difference, divided by 1/2 of rho times v squared. Do note that the pressure needs to be converted to Pascal from PSI. From the 3 different valve configuration, we calculate the mean, the average of the 3 value to determine the mean minor head loss coefficient, and then compare it to a reference table. And we can see in the table 9 that the value is significantly higher, up to 1000%, meaning that there is some flaw in this experiment, resulting in such a high error. The conclusion for this experiment is as follows. First, the minor head loss coefficient for the pipe is 1.88 for 3 fully open ball valves, 35.126 for 9 elbows, and 16.44 for mix of ball valves and elbow. Second, that it shows that the minor head loss coefficient can vary differently between the component used, in this case ball valves and elbow. And it also can be seen that using the value of KL from the first and third experiment, that it also differs from the second experiment when calculated, which show that there is further inaccuracy in this experiment. The third, the experimental minor head loss coefficient compared to theoretical is 1.877 compared to 1.15 for the 3 valve, 16.44 to 1.35 for the mixed arrangement, 35.12 compared to 2.7 for the house arrangement, which means the resulting error of 11.15 1151%, 1118%, and 1201% respectively. Now, this is the suggestion for the experiment. First and the most efficient one is to use an actual flow measuring device such as potentiometer instead of using mass flow rate measured using weight, which will give a much more accurate flow velocity. Second is just throw pressure gauge instead of using one, which will simplify the experiment. 3 is make a more rigid and stable structure, as you can see in the experiment that the supporting structure is not very rigid. And the third is use the pump with higher head and more consistent flow for better experiment result. Thank you. This is for all from our group. Thank you for watching. Assalamualaikum warahmatullahi wabarakatuh.